Hello friends, welcome to DCBA Online. So in this module we are going to study shear forces. What are shear forces? And in the next module again we are going to study what are bending moment diagrams. So basically I'm going to solve three types of numericals and I'm going to solve their shear forces diagrams and also the bending moment diagrams. Alright, and this module basically comprises of four videos. The first one, that is this one which you are watching, is the theory part, and it includes what is shear force, and it'll give you a brief idea about shear force and what is a positive shear force, what is a negative shear force, its sign conventions, and which points are to be considered while drawing a shear force diagram. Okay, so if you already know what is a shear force and you are well versed with its theory, you can skip this video and you can watch the numerical part which is given in the description. Okay, so there are three numericals you can watch. Each link will be given in the description itself. So if you want to stay on this video, let's get started with it. Okay, so what is shear force? It's an unaligned forces which is pushing one part of the body. Just a minute. Okay, so they are unaligned forces which pushes one part of the body in one direction and another part of the body in the opposite direction. Let's see this in motion. Okay, what does this statement actually mean? So this is basically a beam, a concrete beam with concrete hatching in it, and there are forces. Okay, now these forces are acting downwards, these forces are acting upwards. So these are unaligned forces pushing one part of the body in one direction and another part of the body in the opposite direction to this. So what happens? Crack appears in the beam and my beam gets separated at that crack. This whole thing points to sort of tearing of the beam. You can see the beam has been torn apart from this section, the section where shear force was maximum due to these forces, these unaligned forces. So I hope a basic fair idea of shear force is being given through this example. We'll see one more example which does not conform with this definition, but it also causes shearing. So here there are not unaligned forces, but there are similar alignment forces, but the magnitude of this force is greater than the magnitude of this force. And because of this, what happens, that the deformation of this part of the beam and this part of the beam is also in the same direction, but this part of the beam goes much below than the other one. You can see it in the animation. So you can see again there is a tearing action, and wherever tearing action is there, it is a shear force. Okay, so to give you a fair basic idea, what shear force does is shear force tears your beam apart at a section, at a particular section. It can be any particular section, you know, like if I consider in this example, if I want to find a shear force here at this arbitrary section, then I'll have to consider all the forces acting to the left part of the beam, all the forces acting to the right part of the beam, and check whether what the summation of these forces do to this particular section, and how much shear force is required to tear this beam apart at this particular section. Okay, okay, so you can watch the shearing action here. It's just simple tearing of the page, but you can see the unaligned forces being generated, and because of that the tearing action of the normal paper takes place. So this is basically what shear force does to your beam also. Okay, I hope this concept is very much clear. Now let us see what are sign conventions of shear force, that is what is a positive shear force, what is a negative shear force. So positive shear force, again we'll consider a concrete beam. Okay, so I'll just consider an arbitrary section x dash, and then if my forces to the left part of this section, the left part of the beam to this section has forces going in upwards direction, and the right part of the section has forces going in downward direction. This condition is met if this condition is true, because for shear force you require two forces which are opposite in direction. So for positive shear force, any one of these conditions should be uh, met. So if my left part of the beam has forces which are going in the upward direction, that is the resultant of these forces, if it is going in the upward direction, then it automatically means that the right part of the beam has the resultant of the forces going in the downward direction. And this is how the tearing of the beam takes place. So left part going up, right part going down. This is called as positive shear force. Left part going up, right part going down, positive shear force. So to sum it up in a statement, we'll say that if the algebraic sum of forces on the left hand side of the section considered is pushing the member upwards, then the shear force is positive. Or if the algebraic sum of forces on the right hand side of the section considered is pushing the member downwards, then the shear force is again positive. So I hope you got the idea of what is a positive shear force. Now we'll check what is a negative shear force by a very basic rule. It obviously has to be opposite of positive shear force. Okay, so again we'll consider a beam, same section x dash, and now for negative shear force, the left hand side of the beam should carry forces which have resultant acting downwards, or the right hand side of the beam should carry forces having resultant upwards. So if this condition is met, this condition is automatically met. So either of them you have to remember. Okay, and this is how the tearing action of the beam takes place, that is the left part going down and the right part going up. Left part going down, right part going up. This is called as negative shear force. To sum it up in a statement again, if the algebraic sum of forces on the left hand side of the section considered is pushing the member downwards, then the shear force is negative. Or if the algebraic sum of forces on the right hand side of the section considered is pushing the member upwards, then the shear force is again negative. You'll understand this better when we solve problems, because in problems we'll be doing it using values, different kind of values, right? The loading values would be there, so the concept would be much better cleared when we solve the sums. But I hope a basic fair idea of positive and negative shear forces being got. So now where should you calculate shear force? This is very important, because a problem, I've here considered all types of loadings, like not all, but I've tried to consider all the types of loadings, which includes a UDL, a point load, a uniformly varying load, as well as a moment. Okay, now where do you consider the shear force, or where the shear force will be changing drastically? So first is at the supports A and B. Second is where point load is given. Point load here it is given at E. Third is point where uniformly distributed load starts and ends, that is C and D. Fourth is point where uniformly varying load starts and ends. So these are the points where you have to find the shear force. Please note that I am not considered H, that is at moment, because at moment there will be no change in shear force. Okay, at moment only bending moment diagram changes, but shear force diagram does not change at all. So you need not consider a moment. We'll see in a sum where I'll be considering a moment, and I'll show that there is no change in the shear force diagram. So these are the points where at support, point load, point where uniformly distributed load starts and ends, and point where UVL starts and ends. So these are the only points where you have to find shear force. Steps to calculate shear force. First is to find reactions, that is VA and VB. That is obviously the first step to any kind of solving. Second is find shear force at all the points that we discussed in the previous step. Here it is A, C, D, E, F, G and B, not H. Now Suppose I have to find a shear force at point E. So what my first step is that I'll have to just take a section just to the left of E. You see this section, it has been taken just to the left of E, and now I have to sum all the forces that are acting on the left part of the beam, or I can sum all the forces that are acting to the right part of the beam. Okay, now why it is done? To check whether shear force is positive or it is negative. So if the resultant of the left part of the beam, that is by considering VA and this UDL, if the resultant of both these, resultant meaning the summation of both these, if it acts in the upward direction, my shear force is going to be positive because left going up is positive, right? Similarly, if this is positive and if this is going up, then if you sum these all these forces, then this has to go down, because if this is going up, this has to go down. Okay, so this is why we calculate sum up all the forces to the left of this section, and then the next step is to take a section just to the right of E. Just to the right of E, again you have to sum up all the forces to the left, in the left portion of the beam, to this section, but now this point load is also included in the left part. You can see here, right? So because of this point load, my shear force might be changed, right? My shear force might get changed. It might, the resultant might come down, or it might stay up as well. So if my resultant comes down, that is the left portion of the beam is going down, this means that my shear force is negative, because left down is negative, left up is positive. Similarly, you can also sum these up, and if the resultant of these forces is upwards, then the right up is negative, right positive. I hope you got this. And now after that, you, when you consider all the sign conventions, you can draw the shear force diagram. So this concludes our shear force calculation theory, and now we can move on to the calculation of numericals and drawing shear force diagrams for three different types of problems. Thank you.